just learned that I can put some images on a whiteboard. And, we're slowly making these videos a little bit better. I want to introduce you to a very important mathematician, Guillaume Francois Antoine Marquis de l'Hôpital. I probably butchered that if any of you guys are native French speakers. But he is a very famous mathematician. Specifically, we have something that we call L'Hôpital's rule. If you want to pronounce it with an actual, French dialect, be my guest. But I'm going to call him L'Hôpital. Please do not call him El Hospital. I think that's a little, you're not even making an attempt at that point. All right, what is L'Hôpital's rule? Well, as an example, I want to take a look at a limit like this. And this is something that actually came up earlier in this class. The limit is x approaches 0 of the sine of x divided by x. And what's important to note is if we just try to directly plug in, this would be the limit as x approaches 0 of sine of x divided by the limit as x approaches 0 of x, which is 0 over 0, which is not an answer. Now, we believe we know what the limit is. And if you look at it graphically, it should be very, very obvious. Now, you can take a very roundabout way of finding these limits, and they're very scientific and they're very mathematical, and you learn a lot. But the point is they're not fast. L'Hôpital rule is a fast way to find what we call indeterminate limits. Okay? And that's ultimately what we want to try and find. What is a fast way to find these indeterminate limits? So, here's what L'Hôpital's rule says. If the limit as x approaches a of f of x is the limit as x approaches a of g of x, and both these things are 0, or infinite limits, if you need to find the limit of both of them, this is going to equal the limit as x approaches a of their derivatives. And as we've seen, a lot of the times, derivatives can make something more complicated become less complicated. We can use L'Hôpital's rule to find some of these derivatives very, very fast. So, what does that look like in practice? Well, let's take sine of x and x. If we call this f and this g, you can see that the limit of both f and g are both 0, which means I can rewrite, using L'Hôpital's rule, that the limit as x approaches 0 of f of x, because I know f of x, of sine of x over x is going to equal the limit as x approaches 0 of the derivatives of sine and x. So the derivative of sine is cosine. The derivative of x is 1. Notice, at this point, the limit as x approaches 0 of cosine is 1. And so we get our answer, which we were expecting, which is 1. So what L'Hôpital's rule is going to allow us to do is anytime you get one of these indeterminate forms, 0, 0, infinity over infinity, you're going to be able to, instead of trying to plug in that value to the functions, you've plugged them into the derivatives, and hopefully that's something that's going to be a little bit easier. Okay, so let's take a look at something like this. Let's find the limit as x approaches 1 of the natural log of x divided by 5x minus x squared minus 4. Okay, so let's just note, natural log of 1 is 0. And 5 times 1 minus 1 squared minus 4 is also 0. This is 0 over 0, which means we can use L'Hopital rule. So this is going to instead be the limit as x approaches 1 of, what's the derivative of the natural log of x? 1 over x, divided by, what's the derivative of 5x minus x squared minus 4? It's going to be 5 minus 2x. And this, hopefully, we can just plug in our 1. So this is going to be 1 over 1 divided by 5 minus 2 times 1, 1 over 3. And there's our limit. And if you want a justification, again, you always have the ability to graph these things. And I always recommend that you take a look at a graph if you have the option. And you'll find that you're wonderfully consistent between these. So let's graph this. Let's find x equals 1. So the important thing to note is on the red graph, at 1 it's undefined. But where is it close to? It is, in fact, close to y equals a third, right? That sort of looks like where that graph wants to be. Now, how do you actually find that point algebraically? Again, that's where we're going to use L'Hopital's rule. But the important thing to note is they're all consistent, right? L'Hopital's rule is just a more procedural way of generating these things that we suspect to be true. Okay, let's look at one where maybe we have to move around some terms, and that's another something that you're going to have to do is sometimes you're going to have to move some terms around. Let's take a look at, here's one, the limit as x approaches e of 10 times the natural log of x minus 10 divided by x minus e. Okay, so note 10 times the natural log of e minus 10 is 0, and x, which is e, minus e, is 0. This is a classic 0 over 0. So what do? As always, we invoke L'Hopital, and it does have that weird caret over the O. This is going to be the limit as x approaches e of, the derivative is going to be 10 over x minus 0 divided by 1. Or we get 10 over e. Which is not a very nice looking answer, but it is correct. And again, we're able to do this because it is in this indeterminate form. And you need it into these indeterminate forms if you're going to evaluate these things. Let's take a look at one that we might not go to 0 over 0, but I'll be honest, most of them go to 0 over 0. Something I do want to point out is you're not able to do this unless you have this indeterminate form 0 over 0 or infinity over infinity. Now, sometimes the indeterminate form doesn't look like it will work, but ultimately it really does. Okay, so I just want to pull up an example. This is coming from your textbook. One of them, it seems like it won't work, but in reality, it does. Okay, so let's find the limit as x approaches infinity of x squared times the sine of 1 over 4x squared. Okay, so as a note, the limit as x approaches infinity of x squared is going to go off to infinity. And the limit as x approaches infinity of sine of 1 over 4x squared is going to go to sine of, as x goes to infinity, this is going to get smaller and smaller, and 0 goes to 0, and we're going to get 0. So this is a 0 times infinity, not L'Hopital yet. This is 0 times infinity, which is bad. So without using L'Hopital, all I could really do is I can rewrite it. Now, I'm going to rewrite this one as, instead of saying x squared, I'm going to let x squared equal 1 over t squared. Okay? So notice, if I want to get this to be infinite, this is now the limit as t goes to 0. Right? Because this is heading towards infinity. This is also heading towards infinity. As it gets smaller and smaller, it's going to blow up to the point where it's much, much larger. Okay? So, let's recast, and this is what this is usually called, recasting, the limit as t goes to 0 of, well, x squared is 1 over t squared. And sine of 1 over 4x squared is now going to be sine of 1 over 4 times t squared. Okay? This is one where as t goes to 0, let's take a quick note, the limit as t goes to 0 of t squared is 0. And the limit as t goes to 0 of sine of t squared, even if they're 1/4, also goes to 0. This is now 0 over 0. This is L'Hopitalable. So now I'm ready to take the derivatives. This is going to be the limit as t goes to 0 of, what's the derivative of sine? Derivative of sine is cosine times derivative of the inside. This will be 2t over 4 all over. Derivative of t squared is going to be 2t. Derivative as 2t goes to 0. Okay. So, what have we gained? Well, derivative of cosine of 1 over 4t squared times 2t over 4 as t goes to 0. This is going to be the cosine of 0 times 0, which is going to be 0, or 1 times 0. And 2 times 0 is also going to be 0. Look at that. We're still in 0 over 0. So, as always, what do? We take another L'Hopital rule. And that's something that's going to happen a lot, is that you end up taking multiple sets of these L'Hopital rules. Now, you are going to introduce an interesting product rule here. Let's just get that worked out first of all. Product rule. We're going to say it's the first times the derivative of the second, 1/2, plus the derivative of the first, which, again, we've already done. Derivative of cosine is going to be negative sine 1/4 t squared times 2t over 4 times the original 2t over 4. It's going to be our product rule for the top. All over. Derivative of the bottom is just going to be 2. So this is the limit as t goes to 0. Okay, let's figure out what we have. Okay, so as t goes to 0, this thing also going to 0. Cosine of 0 is going to 1. This is going to be 1 times 1/2 minus sine of 0 is 0. And this is 0, and this goes to 0. So this whole thing goes to 0 all over 2. 1/2 over 2. We get the value of 1/4. So there's multiple things that you can do. Okay, and I just want to shout those out as Sometimes you want to introduce a division, right? You want to introduce it as a division instead. I will say, if you would rather, sometimes instead of going from x's to t's, because some people don't like to do that, the limit as x goes to infinity of x squared is the limit as x goes to infinity of 1 over x squared. So you can also do it like this, where you keep it as x's, and you end up multiplying pretty much by the same things. So I want to point out right here, if you do that, if you do this transformation, this is going to stay the limit as x goes to infinity. But instead of x squared, we're going to write 1 over x squared. So this is sine of 1 over 4x squared. And this is 1 over x squared. And this is also going to be 0 over 0, L'Hopital formable. So either way you recast it, it'll work. And then sometimes also know you might have to do a double L'Hopital. You might have to do it maybe multiple times. Now, sometimes the L'Hopital doesn't work. So make sure you're recasting them in a correct way. Now, another thing I want to preface, and I want to point out this is wrong. I'm going to write something that's not true, and I'm going to keep it in this box so that you know everything in this box is not true. If we take a look at the limit as x approaches 0 of 3x plus 5 over 2x, if you take a derivative of these, the limit as x approaches 0 of 3 over 2 is 3 over 2. But the problem with what you just did is that the first one doesn't start in L'Hopital's rule. If you take a look at 3x plus 5 divided by 2x, this is not 0 over 0. It's 5 over 0. And you cannot use L'Hopital's rule unless it is one of these strictly indeterminate forms of 0 over 0 or infinity over infinity. And specifically, they need to be the same. Okay? So, I'll be honest, I don't like having this on the screen, but I am going to include this. I'll leave them without x. But just know, everything inside this box is wrong. You can't always use L'Hopital's rule just because you didn't get the answer you wanted. Okay? In fact, the answer here, the limit does not exist. So, L'Hopital's rule is not something that finds all limits, but it is something that finds some limits, and we want to use it to find the limits that we need. All right, that's another week down. Hopefully you guys are keeping up. Again, if you have any questions on specific problems you'd like to see done, send me an email, and I'd be more than happy to do those. I wish you all a wonderful rest of your day, and I'll see you starting next week.